Welcome to today's webinar on an overview of the Droplet product from DigitalOcean. My name is Karan Chhina, and I'm a product manager at DigitalOcean for the compute platform, which includes Droplet as one of its core products. Before I begin, just a couple of notes. I'm going to go over this presentation, and then we'll also switch into my desktop to go through a demo. At any point, if you have any questions, you should be able to open up the questions section in the webinar's console and post your questions there. We'll try to go through them as we go along, and we'll also try to address some of them at the end of the webinar. So let's get started. Today, we're going to be talking about an overview of Droplets. They've come a long way since they were first released about 7 years ago. We'll talk about what they are, their use cases and benefits, the different types of Droplets available, their key features, and then functionality we provide to make it easier for you to secure, manage, save, and scale your Droplets. We'll have a demo where, time permitting, I'll show the Droplet creation process via the user interface and the command line interface and some of the other features. So Droplets are essentially virtual machines that run on top of infrastructure. This is infrastructure like servers and switches and routers in data centers that are managed by DigitalOcean. Customers then have a self-service ability to create droplets of different shapes and sizes, and DigitalOcean manages those droplets, ensuring their uptime, connectivity, performance, and other aspects. You, as users, manage the operating system and the applications that need to run on top of the droplets. Droplets provide the classic benefits of using a public cloud infrastructure as a service. They're cost effective, they have a low upfront cost to get going, and you only pay for the resources you use. You can scale up Droplets to thousands or down to a few as needed. And DigitalOcean ensures that all of the Droplets work with predictable performance, reliability, and security. So you don't have to worry about that. While you as developers and businesses can spin up as many Droplets as needed to quickly go to market in multiple locations around the world if needed. Now, let's take a look at the different types of Droplets. They were first introduced as a single product offering right after when the company was founded. The original Droplet shared CPUs. That is, they came with multiple Droplets shared a single hardware thread on a CPU. And they came in various different shapes and sizes, and all of them came with local SSD storage. They started at $5, as many of you are probably familiar, and for the smallest size. They can be powered up in less than a minute, and were, and still are, extremely easy to set up. Since then, we've launched 3 other types of Droplets. We call them 3 other families of Droplets with more specialized characteristics. In 2017, we launched a CPU optimized Droplet type. And last year, we launched a general purpose and memory optimized Droplets. All of these newer types come with dedicated CPUs. That is, the underlying CPU cores are allocated just to those Droplets. This is important because for workloads that require it, this provides predictability and consistency in performance, especially compute performance. And finally, they all come with blazing fast local SSDs as default storage. So just in a nutshell, standard Droplets have access to shared CPU resources, come in a variety of different plans, and the performance type of Droplets, CPU optimized, general purpose, and memory optimized, all have access to dedicated CPU resources. And I'll talk about more details and more characteristics of these Droplets. So let's drill down a little bit into each of these Droplet types and understand their key characteristics and the types of application use cases they're ideal for. First up, we have the standard Droplets. They have a variety of options when it comes to CPU, memory, and disk choices, and they come with copious amounts of outbound network bandwidth, which, as a side note, can be pulled together from multiple Droplets. So if you have 5 Droplets, You can pull together the outbound network bandwidth from all of those 5 droplets and use it on one if needed. As I mentioned earlier, these standard droplet types share the underlying CPU, the CPU hardware threads, with other droplets. And these are generally ideal for applications that can handle variable levels of CPU. So that is applications that don't necessarily require consistent high CPU use for longer periods. These droplets are great for things like low traffic web servers or blogs, smaller size databases, dev test environments, and if applications are architected in a certain way, even for microservices-based architectures. Next up are the CPU optimized droplets, which are droplets with access to dedicated CPUs. That is, they get guaranteed full access to all of the allocated CPU cores at all times. The key characteristic of the CPU optimized droplet type is that they have a fixed ratio, 2 gigabytes of RAM for every allocated vCPU. So as an example, a 4 vCPU droplet will have 8 gigabytes of RAM. And so this higher ratio of CPU to memory makes these droplets ideal for applications that require guaranteed and sustained CPU performance, and not necessarily a lot of memory. Some examples of use cases for these droplet types are CPU-intensive CI/CD tooling, batch processing of audio and video, whether it's encoding or transcoding or something. Another use case is certain types of machine learning model training and inference, which can be pretty compute intensive, ad serving, and other heavy CPU use workloads. The largest size available for these droplets is 32 vCPUs and 64 gigabytes of RAM, and a variety of different SSD options. Next, we have the general purpose droplets, and they were launched last year. And as the name suggests, these are really best for any general purpose workload that requires dedicated compute resources and predictable compute performance. So the key characteristic of these droplets is that they have a very balanced ratio of 4 gigabytes of RAM for every allocated vCPU. And this really makes them a go-to mainstream option for mid-sized and above web servers and databases, and in general, any other type of production application that doesn't have a specialized high CPU or a high memory requirement. The largest size that's available for these droplets is 40 vCPUs and 160 gigabytes. So that's the 1-to-4 ratio of CPU to RAM. And again, various different local SSD storage options. Next, finally, we have the very recently launched memory optimized droplets. And again, as the name suggests, these have a much higher ratio of memory to CPU and are ideal for memory intensive applications. These are applications that don't necessarily require a lot of CPU compute resources, but are memory intensive, require a lot of RAM to run. These also, as I mentioned earlier, these also come with access to dedicated CPU resources and are available with local disk sizes as large as 4.7 terabytes. And so this makes them really good for running high performance databases or in-memory caches, other real-time analytics and data processing applications, because a lot of RAM and a lot of local high performance SSDs. So the largest size is 32 vCPUs with 256 gigabytes of RAM and 4.7 terabytes of local SSD storage. So those are the 4 types of droplets to sort of summarize: standard, CPU optimized, general purpose, and memory optimized. The key things to note are that the standard droplets share their CPU resources with other droplets, whereas the other 3 droplet types have access to dedicated CPU resources. The And these three specialized droplets have other characteristics like fixed ratio of memory to CPU. And so it goes from 2 gigabytes per vCPU, 4 per vCPU to 8 gigabytes per vCPU, respectively, for CPU optimized, general purpose, and memory optimized. And so depending on the type of workload you have, depending on the type of application needs you have, you can either pick one of the different types of standard droplet types with variable different that share CPUs and have come in different shapes and sizes, or you can pick a more a droplet type with specific ratio of RAM to CPU and dedicated CPUs. It all depends on the use case at the end of the day. So with the types of droplets out of the way, let's drill down into the key features of droplets. Droplets can be created from a variety of different source images. These images can be base operating systems that are offered by DigitalOcean, and these are Linux or Unix-like operating systems like Ubuntu or CentOS, Fedora, and others. You can create a droplet from over 130 marketplace application images that we now have in the DigitalOcean marketplace. And so these allow, once you try and spin up a droplet from a marketplace application image, that application gets pre-installed and it's really easy to configure on that droplet. It's sort of like a one-click application deploy on a droplet. Droplets can also be created from previously taken snapshots or backups of other droplets. And also you can create custom images for your specific use cases to be used as source images for creating new droplets. Droplets and other resources can be organized with the help of projects and tags. And these two entities make it really easy to work with a logical group of resources like droplets and load balancers and IP addresses and others that perhaps belong to a single application, for example. So it makes it easier to work with a group of resources, to logically combine them together and work with them. Snapshots and backups can be taken for the droplets, either for recovering from failures or for creating a gold master image to spin up more droplets of exactly the same type. I'll talk a little bit more about snapshots and backups in a later slide. All droplets come with one public IPv4 address, and that's standard. And IPv6 addresses, public IPv6 addresses, private networking, and floating IP addresses can be configured as well. Floating IP addresses are ones that can float. They're static IPv4 addresses, but can be changed to point to different droplets as needed. And finally, there is the ability to use DigitalOcean Cloud load balancers that can be used to distribute traffic between multiple droplets. And I'll talk a little bit more about load balancers in a later slide also, and how they help with horizontally scaling your applications out. Droplets and the other services that DigitalOcean provides can be deployed in 12 different data centers around the world. These are in 8 different geographical regions around the world. And this is key if it's important for you to support your end users around the world. And you can start small in a local location, in a single location, and then expand into other locations as needed. Attaching more storage. So if the local SSD storage disk that comes with every droplet is not enough, you have the ability to attach remote block storage to your droplet. And this block storage can range in sizes from 1 gigabytes to 16 terabytes. And they come with a lot of features like redundancy with multiple replication, and automatic formatting and mounting, and support for higher IOPS and throughput as needed. Here's a screenshot where you see pretty easy to just select the additional storage that you want to attach or define your own, and it'll automatically format it with a specific file system and then mount it to the droplet. So it's available from within the droplet to use. In addition to storage, securing your droplets. So securing your droplets from outside malicious threats and attacks is critical to protecting your application and your data on the droplets. And so DigitalOcean provides a cloud firewall service that is network-based and stateful. It's very easy to define inbound and outbound access rules. And these rules can limit traffic on specific ports and to and from specific IP addresses or ranges. And also another interesting thing to note here is that tags, which I talked about earlier, which are essentially just labels on resources, can be used to automatically add multiple droplets to the firewall service. So as an example, if you create a firewall with that uses a tag called web server, and then you create multiple droplets that are tagged with that tag, it becomes really easy. Every time you create the droplet, it'll automatically get added to that with that cloud, behind that cloud firewall. So it makes it really easy to set it up. You can always set up firewalls locally on your droplets as well, like the UFW or IP tables or other configurations, but a network-based cloud firewall service makes it really easy to manage a larger number of droplets at a point where the traffic doesn't even reach the droplet yet. Very, very powerful, very easy to use, and highly, highly recommended. Another key aspect for security is the ability to use SSH keys for authentication into your droplet. So we provide SSH keys and password-based authentication mechanisms to log into the droplet. However, SSH keys are highly, highly recommended, and if they are enabled, then password authentication is disabled by default. We make it really easy to, in fact, we provide in-product instructions on how to generate a key and add it to your droplet during the create process. Setting up droplets is easy and quick, but after they are up and running, we provide a way to configure a metrics agent on the droplet. You can do that. You can do that during the droplet create process, and then also after the fact by just running a very simple command. And this agent can then start collecting various metrics like CPU, memory, disk utilization, disk I/O, the bandwidth that's being used, and load in general. And then you also have the ability to set up thresholds and alerts so that you can be notified if any of those metrics breach a defined threshold. So this is great if you want to just monitor your droplet for various different metrics for the various different resources that are on it and get alerted by it. The alerts can be email alerts, they can be hooked up into Slack or webhooks or PagerDuty and other things. So setting up droplets is easy and quick now, but as the applications grow in size on your droplets, then they may need access to more compute resources. And so this is where we provide the ability to vertically scale a droplet up or down. So there are two options that are available here. If you only want to scale CPU and RAM only, the droplet can be either scaled up or down. So it can increase or decrease the CPU and RAM size, but not the disk size. And the other option is where if you want to scale CPU, RAM, and the local disk, the droplet can only be scaled up. Another thing to note is that droplets can be resized to different types. So as an example, from a standard droplet type to a memory optimized droplet type. And this makes it really easy for you to start your application on a smaller standard droplet and then resize it to a larger, say, memory optimized or general purpose droplet as and when needed. You know, when you start seeing more traffic or when you want to make it into a production application or whatever the case might be. On the right-hand side here, you see the two different options to resize a droplet. The one other thing to note is that to resize a droplet vertically, you have to turn it off. So the application has to be shut down, the droplet has to be shut down. You resize the droplet into the different types depending on your use case, and then you restart it back up. And it'll spin up a new droplet, all of your data is intact, and the newer configuration is available. The other type of scaling capability is horizontal scaling. and it also assists with introducing resiliency into your applications. And this is where we provide a network load balancing service that can be used to distribute traffic to an application on multiple droplets behind the firewall. It comes with many features like automatic failover and the ability to easily configure SSL certificates on the load balancer using Let's Encrypt. Also, you can also use tags, much like adding droplets to firewalls. You can also use tags to automatically add newly created droplets to load balancers. So there are ways to automate scaling up or down droplets behind a load balancer as needed. So once the droplets are configured and secured and sized correctly, you then have the ability to take a live snapshot of the droplet. And so this creates a disk image of the droplet on demand. Snapshots can be really helpful as you're configuring your droplet. So let's say in case something goes wrong, you need to, and let's say something goes wrong while you're trying to configure the droplet, and you need to revert back to a working configuration, you can always go back to a snapshot and spin that up. Another way snapshots can be really helpful are as templates for other droplets, or sometimes they're known as gold master images. And so what happens there is that you create a standardized configuration of a droplet. You set up a droplet, you configure it with the application or however, all of the whatever you're running on it, the way you want it, and then you save a snapshot of that configuration. And now you can use that snapshot, or also known as a template, to spin up multiple different droplets of that same type. And they're all, that'll ensure that they're all configured in the exact same way. Finally, you also have backups, which are very much like snapshots, except that you have to enable them, and once enabled, they are automatically taken once per week. So they're not on demand, they're automatically taken at a specific time once per week, and then each backup is retained for 4 weeks. And so these are more for cases where you want to prevent data loss, and you want to be able to recover from data loss events. Finally, I wanted to call out that all of the capabilities that I talked about, specifically for droplets and all of the add-ons and associated products and services around it, all of those capabilities are available for you to use via very easy and simple to use interfaces. We provide 3 different types. You can control all of your infrastructure through a cloud control panel user interface, a very easy to use API that helps you automate. Yeah, so I was talking about the simplicity of using different types of interfaces, whether it's a user interface or an API or a command line interface. And I'll show some of these to you in the demo section. And another very important thing for a cloud environment is to provide access to very simple and easy to understand pricing and billing. So we provide both a very transparent pricing page and a very transparent and, more importantly, predictable billing on a monthly basis. So this ensures that you know what you're getting, the prices are fixed, you know what to expect, and then once you start getting invoices and bills, having that transparency and predictability ensures that you're never taken by surprise with a bill. If you spin up 5 droplets worth of $20 each, you know you're going to get a $100 bill every month, and not something crazy. They come with free inbound network bandwidth and copious amounts of outbound network bandwidth. And as I mentioned earlier, that network bandwidth can be pulled together from multiple droplets. So it really helps ensure predictability in the billing. And so with that, let me get into a demo. I'm gonna go ahead and open up. Go ahead and bear with me for 1 second. Okay, go to cloud.digitalocean.com. And as you can see, I have, when I first log in, I land into a project page. A project automatically collects multiple different types of resources like droplets and other resources like databases and Kubernetes and clusters and other things in one place. I can go ahead and drill down into one of the resources, one of the droplets here. I just set this up a little while ago, and so it's just started collecting some metric information because I set up a monitoring agent on it. I have the ability to launch a console from right here to log into the droplet, or I can log in using SSH, and which I'm going to do now. So I'm going to go ahead and copy just the IP address. And so that makes it really easy to just, oh, this one's configured with the password. And so I have real quick access to the droplet right there. I have the ability to turn off droplets or power recycle them from here, the ability to add additional volumes to the droplet. And so these are the attached block storage that I can attach to a droplet if I need more storage than what's available. Then I have the ability to resize droplets. I showed this in one of the slides. Once I turn off the droplet, I can go ahead and change the configuration and choose a different type, and then resize it to that different type. Resizing can take a little bit of time. It takes about a minute per gigabyte of data that's used by the droplet. So, and then also remember, you can go up in disk size, but cannot go down in disk size. Networking capabilities, there are, so private networking can be enabled. Public IPv6 can be enabled. This droplet is configured to be behind a firewall. And so you can see what the inbound rules available here are. It's going to accept traffic on port 22 from all IP addresses. And then the outbound rules are configured here. I can click here and it'll take me to the firewall section, and it'll show me the other droplets that are behind these firewalls. I used a tag called FW applied, and any droplet that's created with that tag will automatically get added to this firewall. Going back to the droplets, and then you can destroy droplets and look at the historical actions that have been taken on the droplet, create more tags and things like that. So once you have, so let me just take you through a droplet creation process. Again, very, very straightforward and simple. You choose an image, many different images available out of the box. These are base images, operating system images, as we call them, of different versions. And then you have access to marketplace images. This page right here only shows 6, but if you click on the See All Marketplace Apps tab, it takes you to a marketplace portal where there are over 138 at the time, different application images that are available to be used for source images of for Droplet. So as an example, if you want to set up a Node.js based Droplet, you can just click on Node.js, look through the instructions, the different versions that are going to be installed, how to get started after deploying the image, firewalls that have to be opened up, et cetera, and then go ahead and click the Create Node.js Droplet image. And what that'll do is it'll use that as the source image for the Droplet. So just for this purpose, I'm just going to go back and choose an Ubuntu-based Droplet. The 4 different types, you have the starter kind of the standard droplets, which come from $5 to $960 per month type of droplets, and then the performance droplet types of general purpose, CPU optimized, and memory optimized. So you select a memory optimized droplet as an example, and for some of the droplet types, you also have the ability to configure how much local SSD storage you want. And so in this case, you can pick a 3x SSD. So the 1x SSD is, as an example, 50 gigabytes on this $90 plan. a 3x makes it 150, and then 6x makes it 300. So the largest size is almost 4.7 terabytes there that can be configured on a droplet. All right, go back, and I'm going to go ahead and configure a 2 gigabyte 2 vCPU standard droplet. I'm going to skip adding a volume, but it's really easy to just go ahead and add a volume here and pick the data center region that I want this droplet to be in. I want this to be in New York 3. I don't need private networking because this is the only droplet I'm going to be using, let's say, for my example. But you can set up private networking, and that enables intranet, so internal droplet to droplet private networking capabilities. I don't need the private IPv6 address. I'll select it nonetheless. Monitoring is enabled, and that'll deploy the monitoring agent. I will use a SSH key to log into this droplet, and as an example, you can add more SSH keys by simply following the instructions that are on this dialog box. And so that will by default disable password authentication on the droplet. So this makes them really secure against the brute force attacks, where malicious actors are just trying to brute force connect to your droplet and trying to determine all variations of different passwords. So once that is set up, you have an option to select the number of droplets you want to create. In this case, I'll just go with 1, give it a name, apply any tags. I'm going to go ahead and apply the tag that I have applied to 4 other droplets. So that's the FW_apply tag. I can add these to different projects. I only have one project here called Team B. So that's the one that's going to stay on, and I'm going to enable backups on this. Backups are chargeable, additionally, in addition to the price of the droplet, and so they're charged at 20% of the price of the droplet. I'm going to go ahead and create the droplet, and it'll go ahead and do that. So now I just wanted to point out that if I go to, let's wait for this to come up. It usually takes about 25 to 30 seconds, depending on the size of droplet and the location you're trying to spin it up in. And the droplet's up. So now you can go ahead and copy the IP address and connect to it. But I wanted to show you, if you go into the networking and firewalls, you'll see that the count has increased to 5, and this droplets are automatically being added to the firewall that we had set, the firewall service that we had set up. So it's really easy to, and firewalls are no charge, and you should, I highly recommend that you use them for setting up droplets. And so in this case, you set up a firewall service once, and as long as you create droplets using tags, they'll automatically be secure, and you don't have to worry about different types of configurations or different types of droplets for firewalls. So that is, and so while we're in the firewall section, really easy to set up a firewall, give it a name, different types of inbound and outbound rules, and then apply them to droplets. I'm going to go back into the load balancer section, and so this is where you can create a load balancer. Pick a region. It tells you where your droplets are, so that makes it easier for you to pick a region where you want droplets to be behind the load balancers. And so in this case, I'm going to pick New York 3. And again, you can set up different types of forwarding rules. So whether it's HTTP or TCP from the load balancer onto the droplet. And there's a lot of advanced configurations you can set up, different types of algorithms, whether it's round robin or least connection algorithm, etc., and health checks that you want to set up. Give it a name and create the load balancer. I'm not going to create the load balancer here because I don't have any kind of a service running on port 80 on any of those droplets, so it's just going to show as as being down. Besides load balancers, floating IP addresses, pretty straightforward to set up. Add a floating IP address and then assign it to a droplet, and then you can always change it from one droplet to another droplet. And so this is a public IPv4 address that can be moved from one droplet to another droplet. We also provide a domain, a DNS service that enables you to easily manage domains. So as an example, I can manage SammySharkVideos.com. I don't have that domain. I'm just showing you an example where you set up that domain name with DigitalOcean, and you can set up the different records, DNS records for it. Here. Images is the other section where all of the snapshots and backups show up. I have a backup, a snapshot each for each of those droplets. And by the way, I can use these snapshots to create more droplets of that type, that specific type. I can also move around snapshots from one region to another region and so on. I don't believe I have any backups, but once configured, like I said, they are taken once a week and retained for 4 weeks. Custom images allow you to upload a custom image that can be used as a source for droplets. So besides these, let me just quickly show you how to use the command line tool. So I'm going to go ahead and clear out. So the command line tool is called Doctl, D-O-C-T-L, and you can just install it using Brew or other ways. It's available on GitHub. And once you configure it to use with your droplets, once you configure it to use with your DigitalOcean account, then you can do things like list droplets. So as an example, this will list all droplets and result in a format of ID name, IP address, memory, vCPU, and filter it out with tags that are called FW applied. So if I run this, these are all the droplets I have. So now I get a really easy to use command line interface to work with infrastructure. I don't necessarily have to go into the user interface. Another example of creating a droplet is droplet create. And so I have this command here. It'll create a droplet called, I already have a droplet. So I'm going to call it 6, 7, 8, drop 9, drop 10. So it'll create 5 droplets of an image type Ubuntu 18.4 in the New York 1 region of the size type 1 vCPU, 1 GB standard, and then the result's going to be shown in a format like this, and then it's automatically going to apply a tag called FW applied, which means that all of these droplets are automatically going to be added to the firewall that we had defined earlier. So go ahead and, oops, probably missing something here. Okay, I think I'm missing something here. So I'm gonna, let's see, I think I have okay, I'll skip this one now, but it's probably missing one of these command line parameters. So that's the command line interface. And the same way, we have a very easy to use API. And so if you just go and Google DO API, it comes up with the API documentation that shows you how to configure it to be used with your DigitalOcean account, and then call different endpoints, different API endpoints to work with droplets or any of the other resources that we have. Okay, great. So that was a brief demo. I just wanted to point out a couple other things here. Besides droplets and volumes and images and networking and monitoring, we also have a few other products like Kubernetes. Kubernetes clusters are really easy to set up. They run on top of droplets as worker nodes. And so you can just go into the Kubernetes section and create a cluster, define the number of nodes, and these node machine types that you use are essentially droplets that we talked about earlier. And similarly with databases, you can, this is a managed database service that supports Postgres, MySQL, and Redis. Again, runs on top of droplets, but makes it really easy, and you don't have to manage any of the aspects related to managing databases. Right, so I'm going to go back to my slides and recap, basically. So the entire DigitalOcean product ecosystem comprises now of droplets, which we talked about in detail, block storage, which is attachable and scalable volumes, block storage volumes. Spaces along with a CDN is a very simple to use object storage service. So if you're building applications that need to access a lot of images or video or other files that can be stored as objects, you can use spaces and then spread it out around the world, and makes it really, really performant to deliver to your end users via the CDN capability. And that's included and that's free to use, the CDN capability. Managed databases, like I mentioned earlier, Postgres, MySQL, and Redis. Kubernetes clusters can be set up, and they support things like auto-scaling of nodes, and I think we support 3 different versions. Then we have load balancers to help easily distribute traffic, cloud firewalls to secure all of the droplets infrastructure with inbound and outbound rules. We can set up DNS, floating IP addresses, and marketplace.